Hi everyone, welcome to my YouTube channel. So let's talk about this problem. So I've been talking about dynamic programming for the past two videos and I thought it is a good time to talk about a different topic but closely related to dynamic programming. So let's talk about a problem where we can use greedy approach. So this is problem and you can pause this video for now to read the problem and the example and constraints. Okay, so we have to merge or connect sticks until there is only one stick in the array. From the problem, you may be tempted to apply dynamic programming right away because you see the word like quantifier like minimum, maximum. But you have to be very careful about applying dynamic programming to problems that have such quantifier like maximum or minimum, because some problems cannot be solved by dynamic programming. So you have to be very careful when to use dynamic programming or when to use greedy approach. So for this problem, you have to use greedy approach. And so why do you think DP is not the right approach here? So I want you to think about it, why dynamic programming is not the right approach for this problem. So what is the difference between dynamic programming and greedy approach? So let's see the examples. So the first one we have sticks 2, 4, and 3. So we pop the two lowest numbers, so there will be 2 and 3. So you add them, there will be 5, and then that will be our cost. So our cost will be here 5, and then you put that 5, that's 2 plus 3, back into our queue. Our array. And so they will give you 5 and 4. Now you find two lowest number. In this case, there will be 4 and 5. You add them, and then you add these two numbers to the cost. So our cost will be 14, and your array will be left with only one element, so 9. Since we only have one element, we return this cost. And then you look at this problem, this example, 1, 8, 3, and 5. It's pretty much the same. So you pick the two lowest number, there will be 1 and 3, there will be 4. So your cost will be 4, and then you put 4 back into your array. So you have 4, 8, and 5. You pick the two lowest number, there will be 4 and 5, and then you add that number. So there will be 4 and 5 to cost. So your cost will be 13, and then you are left with 8 and 9. And you keep going because you still have more than one elements. So you connect these two guys, and then you are left with 17, and you add 17 to this cost, so your cost will be 30. Now you only have one number, you return this cost. So I already gave you a hint here, but this kind of problem, I think you should use min heap like this. Heap queue module from Python, you use min heap, and that's the right choice to solve this problem. So see how we can write this code. Okay, so let's write a code for this problem. So okay, we need to get min heap, so we will be importing that heap queue module. And then let's see. And then here if you look at here, in this case, when you have one element, so when sticks has only one element, then you just return 0. So there will be what? So if length sticks is equal to 1, then you return 0. Now, and then now you heapify that stick. Heapify sticks. So you heapify given sticks, and you initialize cost to 0, and you run the while loop you run the while loop until you only have one stick left. So it should be while length of sticks is greater than 1. So you run this while loop until your length of stick is greater than 1. If it is equal to 1, we will exit the while loop and we just return the cost. So we pop the lowest element, the lowest number, and we call that cost 1. So there will be heap q dot heap pop, heap pop, and then we have sticks. Cost 2 will be the second lowest number, heap q, heap pop, sticks, and then you add these two numbers and you add them to cost. There will be cost 1 plus cost 2, and then you have to put this number back into our our mean heap. So there will be heap q dot heap push and sticks with cost 1 plus cost 2, and then you run it until the length of stick is greater than 1. If it is equal to 1, then we return the cost. That should work, and let's see. Oops, forgot about this guy. Okay.